Hello everyone. Today in our video we will be discussing chemical equations. So atoms are of course made of matter. That means that they cannot be created or destroyed through chemical action. Now there is radiation action, which is a little different, but we're not talking about that. Fusion and fission, where there's the conversion of mass into energy. But in a normal chemical reaction, we have to obey the law of conservation of mass. So that means that the amount of particles going in must be equal to particles going out, or the mass of reactants must be equal to the mass of product. And this is how all aspects of our lives progress. So let's look at something like simple like photosynthesis. So in photosynthesis, a plant takes carbon dioxide and water, and it makes oxygen and sugar. Now, of course, it does require a little bit of sunshine, a little bit of energy, but those sugar molecules then provide food to animals, but they're also used by plants as basic building blocks to make things like starches and cellulose and those are other ideas. So the idea here is that a basic sugar molecule like glucose, which is made of 6 carbon atoms and 12 hydrogen atoms and 6 oxygen atoms, or C6H12O6, is the product of a reaction between carbon dioxide, which goes into a plant, and water, which goes into a plant. So these are the two things you need to feed to a plant in order to produce sugar and oxygen. And in order for this chemical reaction to proceed, it must obey the law of conservation of matter. And this becomes essentially like an equation in mathematics. In an equation with mathematics, if we write 2 plus 2, then on the other side we must add an equivalent value. And something like 4, for example. 4 is an equivalent value to 2 plus 2. Or if or 1 plus 3, whatever it is, it must be equivalent to the same value, the same amount of stuff. So if these CO2s must be equivalent to the amount of sugar, well, there are 6 sugars over here, so we're probably going to need 6 of those CO2s. This gives us 6 carbons on this side, and now 12 oxygens, but we're a little short on hydrogen because we do see that there are 12 hydrogens over here. So let's make that 6 of those waters. 6 waters would give us 12 hydrogens and an additional 6 oxygens. Well, that's good because if we take these 12 hydrogens, these 6 oxygens, and these 6 carbons, we can add up the 12 and the 6 oxygens that we needed. But what do we do with these 12 oxygens over here? Well, we notice that the other product of this chemical reaction is oxygen. So 12 oxygens on the left, we could make 12 oxygens on the right by saying that there was 6 of these O2s. So that's called chemical balancing, and it's something that I want you to be able to do by the end of this unit, even by the end of this lesson. Here's another schematic for how this might look. Here we have the 6 carbon dioxides. This is our CO2. We have the 6 waters, 6 H2Os, 6 carbon dioxide. And we have the 1 sugar, C6O12, or O6, sorry, and H12, or I think I've got them out of order, don't I? Let me just move that. And CH2HO, okay, there we go. And we have the 6 oxygens. And if we want to count them up, we can count them up any way you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So there's 18 oxygens on the left. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 oxygens on the right. We could do the same thing with the carbons if we like. We could do the same thing with the hydrogens if we want. And in the end, we would see that the number has been conserved. So the mass is conserved. If you'd like to read this thorough description of this process, feel free. But I do want to attract our attention to some terms here. This term, in this thing in front, this number we put in front of the molecule, is called a coefficient. It's how many times you have that molecule in your reaction. This is important because the whole molecule comes with each of these numbers. So 6 CO2s implies that there are 6 complete units of CO2, which is why we get the 6 carbons and the 12 oxygens from that 6 CO2. The arrow here indicates that the chemical reaction, it can be treated like in mathematics as sort of like an equal sign, in terms of the matter on the left and the matter on the right have to be equal in amounts. Now, of course, small subscripts, these are the numbers for the chemical formula, so we already know what those do. Those only affect the number, the element directly before it. So that's 2 oxygens. And finally, these are phase symbols. There are a couple different ones. There are about 4 phase symbols that are important. The solid phase, S, the liquid phase, L, and the gas phase, G. And they should be presented as on the line phases. There is one other one that we will discuss in grade 11, which is the AQ, and that stands for aqueous, and that means dissolved, which is the same as dissolved. So sometimes like sodium chloride, we might dissolve that in water, and it becomes aqueous sodium chloride. All right, so use the illustration and equation for photosynthesis on the previous page. We can write that out again. 6CO2 plus the 6H2O gives us the C6H12O6 and oxygen. And we get 6 of those. I think it's very interesting how it's like such a perfect equation. You know, it tells you something about the way the universe works. It likes numbers that are sort of, that have some sort of order to them sometimes. Sometimes, not always. And I'm just going to make that oxygen a little bit bigger. Okay. So how many carbon are there in the reactants? So we look for the carbon atom. We see there's a carbon atom right here, and there's a 6 in front of it, but no subscript. So that means it's only 1 carbon. So 1 carbon times 6 means that we have 6 carbons. How many carbon atoms in the products? So we have a carbon atom here again in the products, but this time the 6 is to the right. This still has the same effect, 6 times the carbon. So we get 6 of those, 6 carbons. How many hydrogens are there in the reactants? Well, in this case, we have 2 numbers to consider. We have 2 times hydrogen, and then we have the further 6. So that's 2 times 6 gives you 12 hydrogens. 12 hydrogens. How many hydrogen atoms are there in the products? Well, let's look. Oh, this is nice. It is the subscripted version. That subscript affects the element that precedes it, so that would be 12 hydrogens. How many oxygens are there in the reactants? Now, this one is the trickiest one of the set. Here we have to consider the 6 times the oxygen. So that would be, there are 2 oxygens in every CO2, and we have 6 CO2s. So that gives us 12 oxygens. But we also have 6 waters, and there's 1 oxygen in every water, so that's another 6 oxygens. Add those together, you get your 18 oxygens. Moving over to the left, we have 1 sugar molecule, and that 1 sugar molecule has 6 oxygens. 6 oxygens, and each oxygen has 2 oxygen atoms, so that means that we have another 6 times 2 oxygen. And that's going to be another 12 oxygens. And then you add the 12 to the 6, and we get 18 again. Are any atoms destroyed or created during this reaction? And we would say that there are none because the numbers are equal in all cases. So, no. Chemical reactions do not already come balanced. They must be done before the equation can be used in a chemically meaningful way. A balanced equation must have equal number of each type of atoms on both sides of the arrow. An equation is balanced by using coefficients in a somewhat trial and error fashion. The coefficient multiplied by the subscript gives the number of atoms present. Multiply the coefficient by the subscript to find the total number of atoms of each element. So let's practice here. We have a 2 times water, so 2 times the hydrogen would give us 2 times 2 hydrogen, which is 4, and 2 times 1 oxygen, which means 2 oxygens. So 2 oxygens and 4 hydrogens. I know that almost looks the same. All right. The next one, we have 3 magnesium hydroxides. So the 2 is multiplied by each of the elements inside the brackets. That means that there are 2 oxygens and 2 hydrogens, and there's only 1 magnesium, but then the 3 has to be multiplied by all of them. So 3 times, and 3 times. So notice how the 3 affects all of the numbers, but the subscripts only affect the one element. This means that we end up with 6 oxygens and 6 hydrogens. All right, we have one more to do. This one we have 2 times ammonium sulfide. That means that we have, from the ammonium sulfide, we can see that there is a 2 times the 1 and a 2 times the 4. So that means we have 2 nitrogens and 2 times 4 hydrogens. And we have 1 sulfur. But then the 2 in front becomes a 2 times and a 2 times and a 2 times. It multiplies by everything. This affects every element. So that leaves us with 4 nitrogens in total. 2 times 2 times 4, that's 16 hydrogens and 2 sulfurs. There are some steps you can use that when you are given an unbalanced equation that needs to be balanced. We will use the unbalanced equation for the production of water, for example. First, determine the number of atoms for each element in the molecule. Molecules of reactants and products. A T-chart can help. So a T-chart is to do something like this. Divide this up and just try to keep track. I like to keep them tracked on a single line. So I like to go like 2 hydrogen, and then down here I'm going to write 2 oxygen. And then for my water, I'm going to put them together. So 2 hydrogen and 1 oxygen. And then anytime I put a coefficient, I'm going to try to keep the numbers together like this. So let's see. So if I have my hydrogens are already balanced, the next thing would be to balance things that are not equal. So I would like to balance the oxygens, and I'm going to do that by putting a 2 in front of this bracket. So the 2 here will affect both. That means we have now 4 hydrogens and we have 2 oxygens. So the oxygens are now balanced, so that's great, but now the hydrogens are unbalanced. Keep moving forward. Match the hydrogens now by putting another 2 in front of that bracket. We could even put like little brackets around everything. That might make it more straightforward. So this 2 is representing a coefficient of 2. This 2 represents a coefficient of 2 as well. And now we have 4 hydrogens. So in the end, we have 2H2 plus O2 gives us 2H2O. Let's read if there's any other advice that's valuable here. Use the coefficients to balance the equation. Use coefficients to balance metals first, then nonmetals. That can be helpful. We don't have any metals here. Leave single elements and diatomics to balance last. We did leave our hydrogen to balance last. Leave oxygen and hydrogen until the end. This will make it easier to balance. If possible, reduce the coefficients to the lowest number. So let's look and see. So we have 2, 1, and 2. There's no way to reduce that. 1 cannot be reduced. But if you had 4, 2, 4, like here, then you could divide by 2 to bring it down to 2, 1, 2. So as long as the ratio is the same. Note, it is important to note that only the coefficients can be changed. So this is very important. You can never change the subscripts because that changes the compounds. So this would be a cheat, right? If you change this to H2O2, then you've just created hydrogen peroxide, which you do not want to drink. That's very poisonous. Okay, let's try this one. We have our equation. They've given you a way of setting it up. Notice that on the left side, carbon and hydrogen are stuck together. And on the right side, carbon and oxygen are stuck together. I'm actually going to suggest we do this a little bit differently. I'm going to write it out this way. I'm going to write the 1 carbon and 4 hydrogens together and put them in a bracket. I'm going to put my oxygen down here and put a 2 in front of it, and then put that in a bracket. So the brackets here are representing each molecular unit. For the carbon, I'm going to put my carbon and oxygen. I want to put the elements on the same side so I can compare them easily, but I also want to put the elemental composition on there and then put that in a bracket. And I know I don't have anything on the hydrogen line, but that's okay because I'm going to get something on the hydrogen line in a second when I do the H2O. So H2O, and put that in a bracket. So now think about it like you can only put coefficients in front of those brackets. So let's see if we can balance it. This is going to be a tricky one. I know, I can already see. One problem I see is there's lots of problems here. I only have 2 oxygens here. I have 3 on this side, so that's a problem. I have 4 hydrogens, and I only have 2 over there. But I do have 1 carbon and 1 carbon. So maybe I can leave that one. I'm going to leave the carbon. I'm going to try not to touch that one right away. So I'm going to try to fix this problem here first, because that looks like an easy problem to fix if I just put a single 2 in front. So 2 times 2, this would give me 4, and this would give me 2 oxygens. Okay. Now I have a total on this line. I have 4 oxygens in total because I have 2 here and I have 2 there. But the carbon's still balanced. The hydrogens are balanced. So I really only want to try to fix that oxygen problem. So let's go see if we can fix it on the left. On the left-hand side, could I make 2 oxygens into 4 oxygens? And by golly, I sure could if I just put a 2 in front. So if I put a 2 here and I put a 2 here, I could work out my problem. Okay, let's try one more time. So make a line to divide it. Make a line like this. Arrange your elements vertically and bracket. Arrange an element vertically and put any numbers that were subscripted into the brackets. Arrange your number vertically and on the same line for the next line. So something like this. And then my H and my Br down here. Okay. So right now, what do we have? What's working for us? Okay, hydrogens are checked. We got enough hydrogen. But chlorine is not. So chlorine is not good. We got 1 on the left, 2 on the right. The magnesiums are checked. We're good for magnesium, right? Magnesium is balanced already. It did say in the suggestions that we should try to do metals first, but our metals are balanced. But the bromines are not. We have too many bromines. So is there a way we could increase the number of bromines and the number of chlorines without doing too much more damage to the whole thing? I don't know if that's possible, but we'll try. Let's start. We gotta pick one to start with. You're always going to be increasing the smaller number. So if we have 2 chlorines and 1 chlorine, 1 chlorine and 2 chlorines, we want to increase the smaller one. So we're going to put the 2 in front of the HCl. Now this is a problem that it did change our hydrogen count on the left. So what I always suggest is that if you have just changed an element in the same bracket, follow that element and make sure it's checked. Make sure it's balanced. So here, is this balanced now? And it is not balanced. So I need to make sure I deal with that right away. That's the first thing I want to do. I want to kind of follow my train of thought, and then I will kind of work my way around like that and make sure everything is balanced. So I've checked the chlorines now. So I made the chlorines the same. I'm going to go up through that molecule and make the hydrogens the same. So how could I do that? I have 2 hydrogens on the left. I have 1 on the right. So I guess I got to put a 2. And now I'm going to check my bromine now. And my bromine's now good. And then I go back up and check to see if my last element is good. Yes, yes, yes. Everything is equal. And that is a good day. So we're going to just put a 2 in front and a 2 in front of here. So I always kind of, and you can actually usually get away with just picking anything. We could have started with magnesium. The magnesiums would have been checked, moved down to the bromines. We would have balanced the bromine, gone up to the hydrogen, checked the hydrogen. We would have balanced the hydrogen, checked the chlorines, and the chlorines would already be balanced. So just moving around and around the circle. So let's do this next one. And these next ones, I really, recommend that you just take a minute and take a minute, and sorry, I thought I might have stopped my video there. Take a minute and try these out before you watch the rest of the video. So I'm going to arrange them. Calcium oxide in brackets, it's all ones. Hydrogen chloride in brackets, all ones. Calcium chloride with a 2 in front of the chlorine because there's 2 of them, like this. And my H2O, H2O in brackets. All right, I'm going to move around with a green marker. Well, I'm just going to start with metals. So I'm going to check my calciums. Are they balanced? Yes. Move down to oxygen. Are my oxygens balanced? Yeah, so far so good. Move to hydrogens. Are my hydrogens balanced? No. So then we put a 2 in front. Okay, they're balanced now, so I'm going to change that to a check mark. Go down to the chlorine. Move over. Is my chlorine balanced? Sure is. And now we can even follow that back because sometimes we made some changes, and double check. And we are still correct, so we don't have to do any more work. So we just had to put the extra HCl. Okay, I'm going to try that one more time. Try to go a little bit slower. I have a habit of speeding up too much. So here's a sodium. It's all by itself. So that's an easier one. We have 2 hydrogens, 1 sulfur, and 4 oxygens. Oh boy, that's going to be a mess maybe. And then we have 2 sodiums and 1 sulfur and 4 oxygens. So that might be a problem. And then we have 2 hydrogens. So let's just grab our green pen again, and we're going to do some double checking. So, we can start anyway. Let's start with the sodium. So start with the sodium, not equal, change it. Change the smaller one to match, 2. Okay, all fixed. Go down, and here's the tricky part. We have lots of things to check. So let's check sulfur. Sulfur's good. Let's check oxygen. Oxygen's good. Let's go back up to hydrogen and check hydrogen, and hydrogen's good too. So that was a pretty straightforward one. We just had to increase the amount of sodium. When you are dealing with a lot of these, if you notice something that's the same, then you can also just kind of count that all as one thing. So we can kind of count the sulfates. We see 1 SO4 on the left, 1 SO4 on the right. So we do know that's balanced already. Okay, here we go. Copper, back to my red pen, copper oxide together, carbon down here, copper by itself, carbon, 2 oxygens altogether. Uh, we suggested earlier to balance our metals. Well, that looks pretty good, but that is not good, right? So when we get to the oxygen, it's not good. So let's fix that. Let's put a 2 in front of our copper oxide. And so now it's fixed. And then we go down to carbon. Carbon is good. And now we do need to go back, right? We need to go back and check what's going on with our other things. So let's go all the way back to our copper. And we see now that the coppers are not equal. So we do have to double check always. So always try to make a full circle in your work here. Double check that full circle. We've matched it. Now we're okay. So anytime you do it, and feel free to go around and around and around as many times as you like. You can double check. Oxygens are cleared. Carbons are cleared. Coppers are matched. Oxygens are just go around and around until you're satisfied. Okay, let's try one more time. We've got a zinc. Oops, I said we were doing red pen. We got zinc. We have HCl together. We have 1 zinc and 2 chlorines together. And we have 2 hydrogens together. So we can start anywhere we want. Let's start with the zincs. The zincs are fine. So let's go down to the chlorine. Chlorine is not fine, so let's fix it. Now we go up to the hydrogen. We haven't fixed anything we didn't change anything in the past, so we don't have to worry about that yet. And we check that, and it's good. So good. Go back to the zinc. We're good. Yeah, so I think we're okay. So what did we add? Double check what you added. Make sure you got it figured out. Okay, an aluminum all by itself. An iron, 2 of them, and 3 oxygens. Okay, then we have an aluminum, 2 of them, and we have 3 oxygens. So far, looking interesting, and 1 iron. Okay. Aluminum is not matched, so we need 2 of those. Oxygens are matched, correct. Iron, not matched, but we can add a 2 here on the right, and we fixed it. So 2 and 2. Done. We can move back to the beginning, follow our train back at the beginning. Aluminum and aluminum's all matched. All right, so please fill out this sheet if you can. I will try to fill this out ASAP and post it online for you so you can check your answers and have fun with it, and hopefully it all goes well for you. And best of luck.